All right, we're going to solve some radical equations today, solving equations with the radicals in them. So let's do it. Steps we're going to use. Number one, we're going to isolate the radical on one side. That's the very first step. If there's stuff with the radical, it's moving. We're going to isolate it, get the radical all by itself. Number two, we're going to raise each side of the equation to the same power as what the index is to obtain a linear, quadratic, or some other type of equation. And step three, we're going to solve the remaining equation using techniques that you already know. And finally, we're going to check your answer. And I mean, we really got to check today. You got to check your answer. Okay, let's try one here. Cube root of 2x plus 7 equals 3. What we just talked about, it's isolated already, so we're going to raise each side to the same power as the index is to make it cancel. So I'm cubing both sides. On the left-hand side, the radical just gets canceled out. Right-hand side, everybody knows 3 cubed is 27. Moving the 7 to the other side, that gives me 20. Divide by 2, I get x is 10. And there we go. Check your answer. Plug 10 back in there. If I put 10 in there, 2 times 10 is 20 plus 7. Cube root of 27 is 3. It works. Next one, x plus 2 to the 3/4 power, fraction exponent. Fraction exponent, remember, is a radical. It represents a radical, so move the 1 to the other side. Isolate it. X plus 2 to the 3/4 power. That's supposed to be 3/4. That's terrible. Trying to fix that. 3/4, a little better. Equals 8. Now, what we're going to have when we have a fraction exponent or rational exponent is we're going to raise both sides of the reciprocal power. So the reciprocal of 3/4 is 4/3. That's 4/3. So on the left-hand side, the exponents just cancel each other. So I get x plus 2. On the right-hand side, I'm going to work out 8 to the 4/3. So it's really this. It's really 8 to the 1/3. To the 4th power. The cube, remember 1/3 power means cube roots. It's really 2 to the 4th power, which is 16. So x plus 2 is 16. So x is really 14. And there you go. Check your answer again. Plug it back in over here. 14 plus 2 is 16. The 4th root of 16 is 2. Cubed is 8 minus 1 is 7. It works perfectly. Great job. Okay, extraneous solutions. Sometimes you're going to get a solution. When you raise, especially when you raise each side of an equation to the same power, you're basically increasing the number of solutions you could possibly get. So you may introduce what are called extraneous solutions. Extraneous solutions come from the word extra, which means extra solutions, which means you may get solutions that don't work. And if you don't check them, you won't know. So always, always, always check your answers. By the way, check your answer every time. All right, so 2 more here. We'll be done. X plus 1 equals the square root of 7x plus 15. The radical's already isolated, so I'm going to square here, square there, square, square everywhere. Now, the right-hand side is easy, just 7x plus 15. The left-hand side's easy too, but you got to remember the pattern for squaring stuff. You square the first number, you multiply them together, and you double it, then you square the second one. So you get x squared plus 2x plus 1. Make sure you don't just get x squared plus 1 right there. Now, to solve that, that's a quadratic. I need one side equals 0, so I'm moving the 7x. Ooh, I'm moving the 7x over here with the 2x. That's negative 5x. And I'm also moving the 15 over to join with the 1. That makes that negative 14. So now I'm going to try to factor. I'm trying to think of what factors of 14 would give me negative 5. And I think I know what they are. It's minus 7 and positive 2. So my 2 solutions would be 7 and negative 2. Probably, maybe, maybe not. We got to plug them in. One real neat thing about a negative number, well, it doesn't really matter but if it's negative or positive, but I'd always start on the side without the radical. And if I plug in negative 2 over there, I get negative 2 plus 1, which is negative 1. Guys, there's no way a square root, now if it's an odd root, you can, but if it's a square root, cannot equal a negative number. So if I were to plug negative 2 in on this right side, there's no way it's going to equal negative 1. So negative 2 is out. That's not even a solution. So I'm going to try 7. If I plug in 7 on the left side, I get 7 plus 1, which is 8. So I need to see if that's what I get on the right side. If I plug in 7 here, 7 times 7 is 49 plus 15, which is 64. And the square root of 64 is 8, so that works. One solution at times 7. Now, it is possible that neither one of those solutions work. So you really need to check. Sometimes both of them will. Sometimes one of them will. Sometimes none of them will. So there's no other way around it. You have to check. Okay, last one and the worst one. Really watch this. I'm going to do the same thing. What if you have 2 radicals? If you have 2 radicals, you got to get rid of both of them. So you need to isolate one of them, which has already happened here. So I'm going to square this side. And here's the weird part. I'm also going to square this left-hand side. Okay, if I square the right-hand side, you just get 3 minus x. No big deal. Watch what happens here. The left-hand side, this is the toughest thing that you're going to have to do. If I square this out, I'm going to square the first term, which means I just get x plus 2. The square root goes away. Then I'm going to multiply these two together and double it, which if I multiplied them, I would get 1 on the square root of x plus 2. If I double it, I get 2 on the square root of x plus 2. And then you square the 1, which is just 1. Now that's the hardest step. I hope that made a little bit of sense to you. Now, the bad news is I got a radical still, so I need to get rid of it, which means I got to square both sides again. But I'm not going to do that until I get the radical isolated. So on the left-hand side, I'm going to go ahead and add the 2 and the 1, which is 3 plus 2 on that big square root right there. And over here I have 3 minus x. So I'm moving stuff over before I square. So I'm moving the x over there, join with that x. That becomes a 2x. And I'm moving the 3 over. But the great news is when I move that 3 over, it's gone. So I just have 2x equals 2 on the square root of x plus 2. Now, you don't have to do this next step. I'm going to go ahead and divide both sides by 2 to get that isolated even further. Now, if the only reason I'm going to do it this time, though, is because when I divide 2x divided by 2, the 2's cancel and I just get x. And I like that a lot. I mean, that makes it pretty easy. So square both sides again. Square here, square there, square, square everywhere. The left-hand side, x plus 2. The right-hand side, x squared. Almost there, and you're probably thinking, why are we not there yet? This is the longest type. So to solve a quadratic, I'm going to move everything over. And I want the x squared to be positive. That's why I'm leaving it and moving everything else. I'm moving the x across and the 2 across. I'm going to try to factor, and it will factor. I see x minus 2 and x plus 1. So I get these two answers, 2 and negative 1. Maybe. So I'm going to take the 2, plug it in right here. 3 minus 2 is 1. The square root of 1 is 1. So it means if I plug in 2 on the right-hand side, I should also get 1. 2 plus 2 is 4. Square root of 4 is 2 plus 1 is 3. So 2 didn't work. All right, let's try the negative 1. If I plug negative 1 on the right-hand side, right here, if I put negative 1 in, why is it keeping doing that? If I put negative 1 right there, it gives me 3 minus negative 1, which is really 4. The square root of 4 is 2, which I like. So plug it in right here. Negative 1 plus 2 is 1. The square root of 1 is 1 plus 1, which is 2. The same answer both sides. So the only solution I get is negative 1. And it's good enough. So hopefully that made some sense. That last problem is a doozy. That's not the majority of your homework, but you will need to be able to get some of those done with 2 radicals. All right, so we'll get there. We'll work on it tomorrow. You'll be absolutely fine. And I'll see you then.